All right, so I think this is recording. Go ahead and read this problem carefully, and then identify thing one and thing two, and then press continue. All right, so we have two rental cars leaving the airport at the same time. One car travels east and the other car travels west at a speed that is 8 miles per hour faster. In 2 hours, the cars are 176 miles apart. What is the speed of each car? So let's label thing one as the eastbound car and thing two as the westbound car. So now, using the information given, complete the table and then press continue. All right, so let's see. We have that each car traveled 2 hours. Put my units up here. We're asked to find the speed of each car. So if I just call x the speed of the eastbound car, and it has units of miles per hour, the westbound car its speed is 8 miles per hour faster, so that would be x plus 8. I do not know how far the eastbound car drove, and I don't know how far the westbound car drove, but I do know that their total is 100. They're 176 miles apart from each other, and since they were traveling in opposite directions, I know that their total is 176. Should have made this box a bit bigger, huh? All right. It doesn't make sense since the time is simultaneous, or it doesn't make sense to me anyway, that I would add these two times together. So I'm going to leave that blank. All right. Every uniform motion problem that we're looking at is going to fall into at least one of these four categories, four relationships. We know that distance is equal to rate times time, and rewriting this in terms of distance, or excuse me, in terms of time, that time is distance divided by rate. So which of these four do you think that it's best for us to explore and try to use to solve this problem? Press continue when you think you've made a selection. All right, so I don't think that of the 176 miles, I don't think there's anything in the problem that implies that, especially since they're traveling at different rates, that they've traveled the same distance. I don't think that's a reasonable relationship there. And we've said that it really doesn't make sense to look at the total time, so I don't believe there. So they have each traveled for the same length of time, and we were given the total distance. So it's one of those two that is worth exploring. Now, if you selected the two times are equal to each other, and we try to explore that, I think that you'll find there's too many unknowns. So let's take a closer look at this one, and then decide whether we want to continue or come back and pick that total distance. So if these two times being equal to each other, which we know is that 2 hours, 2 equals 2, and we know that distance divided by rate is what time is. So if I'm looking at this relationship, I want to look at the distance divided by the rate for thing one, and the distance divided by the rate for thing two. and see the rates, we have expressions for those. For thing 1, we said its rate was x, and for thing 2, it was going faster at x plus 8. But we can't come in and say very much about this distance, other than, yeah, this is some distance d1, and you could say that 176 is the total, and if you take away the distance that d1 traveled, then that is d2, because d1 plus d2 is 176. So if we subtract d1 from each side, but see, this is one equation, but two unknowns. So it really does, we run into the problem that we don't have a unique solution for this equation. So I think we have to come back and look at this total distance. Well, once again, this is not letting me there change. I thought that it would not erase our equations, but that's okay. We don't need them. We just want the top one there. All right. So our total distance we know is 176 miles. And we know that distance is rate times time. So let's look at thing 1. The rate is x and the time is 2. So rather than writing x times 2, I'm just going to write 2 times x. And then the distance that thing 2 traveled, if distance is rate times time, then we want the rate, x plus 8 times 2. So I'm going to write the 2 out in front. So now I have one equation and one unknown, and I can solve this. So I have 176, 2x plus 2x plus 16. If I take away 16, I have 164x divided by 4. And I have the x is 40. That is the speed of thing 1, the eastbound car. Can't spell east. East car, and which had units of miles per hour. And we know the westbound car is 8 miles per hour faster. That also has units of miles per hour. So these are our two answers. And I think that's the only thing it asked, right? Yeah, what is the speed of each car? So there we have it. So hope that helps, and I will talk to you later. Bye.